Hello everyone again. So in this recording I will talk about the acceleration and the velocity. So with the initial example I will talk about the gravitational acceleration, which is 9.8 meter per second squared. So what it means is that 9.8 meters per second and then second. So it means at each second the body increases its velocity by 9.8 meters per second. So let's give a simple example. Say that I have a particle and it's in free fall. And then the velocity, initial velocity is 0. So when it falls, according to gravitational acceleration, so in 1 second, its velocity will be 9.8 meter per second. In another second 2, it will be 9.8 plus 9.8, so it's approximately, let's say, 20 meters per second. So at each second the velocity of the particle increases by 9.8 meters per second. This is what the gravitational acceleration tells us. And then here the question says that the distance covered by the car is given. So this is the distance in miles and this is the time in seconds. And then the question says that determine the speed. And for this one, I will tell that the speed, as you know from physics, that is distance by time. And let's write the given values. At first second it is 10 miles, so this part is distance in miles, and this part is time in second. And second 2 is 20 miles, and then 30 miles, and then 40 miles, this way. So we have the distance covered by the object. And then if you try to calculate the velocity, you can calculate the velocity for each section. For example, for this section, the velocity will be 20 minus 10, the distance, by the time, 1 second. So it is 10 miles per second. If you do the same calculation for the next section here, it will be 30 minus 20 by 3 minus 2. And then if you do the same, you can do it for all the sections. I will just show, for example, here, and it will be that the 70 minus 60 by 7 minus 6. So this is how do we calculate the velocity for each section. And then another case is that the velocity can be like, the distance can be like the variable one. For example, at the first second it is 10, then 20, then 30, then 56, and then we have 75, and then we have 96, and then 65, then 55, 45, and then we have the 10. But in this case, if you calculate the velocity, as you can see, the velocity changes in each section. So let me do it for you. For this part, velocity is 20 minus 10 by 1, or 2 minus 1. At the second part here, it is 30 minus 20 by 3 minus 2. And if you look for the velocity in the third case, here, that 56 minus 30 and divided by the 4 minus 3. So this way you can calculate the velocity for each section. And you can see that velocity, here it was the constant velocity, but here the velocity changed. So it was 10, 10, but now it is a 26, and then you can calculate for this part as well. It will be 419, and then you can calculate for this part and for this part. For each section, the velocity of the car changes. And the next part is the speed of the car is given, and then looks for the acceleration. The acceleration will be that the velocity by time. Okay, this is how it looks like in the simple form. This is the simplest form, and then next we will see how it looks like in differential form. And you can see the velocity is always 60 mph, here 60, and then 60. And since the velocity did not change in any section, the acceleration is 0. It did not accelerate. But it can go this way as well. So similar to a path. So this axis is the velocity and this axis is time. Here this axis is velocity and this axis is time. And time in seconds and the velocity in mph. And then it is 10 and then 20 and then 30, 40, 50. This way it goes up to 100. Similar to the first example, and we will do the same here, the acceleration here is that 10 minus 0, 2 minus 1. And then here the acceleration will be 20 minus 10 and 2 minus 1. Similarly, we can calculate the acceleration for each piece of the function. But these are the simple examples that we had. This one is, you can see, linear relationship. Linear relationship. So linear relationship means that we can say that velocity is equal to a times t. And then if you look for exactly what is a is 10. So velocity is 10t. If you check it here, so at the second, okay, sorry, then I believe I made a mistake here. So at the first second it is 0. So I will correct it. So I made a mistake here in the values. Let me correct it. So again it is linear, but the functional relationship is a bit different. So at the first value, the time is 1, the velocity is 0, and then velocity is 10, and this way it goes. And then if we calculate for example, from 2 to 1, so it will be here 10 minus 0, 2 minus 1. And then here similarly, in this section, 20 minus 10 and 3 minus 2. So it will be velocity by mph. So again, you can see it is a linear relationship, but now it will be that the velocity is then a times t and plus b. It's not a at relationship. You can find this one easily. When time is 0, when time is 1, v is 0. So 0 is a times 1 plus b. So from here. So it follows that a is negative b. So if I replace it back, so it will be that velocity is a times t minus 1. Okay. And to find the value of a, I will use the second or any value. You can use it here. So when time is 2, the velocity is 10. So the 10 will be equal to a times 2 minus 1. So it will be from here that a is 10. So this functional relationship is velocity is 10 times t minus 1. You can replace it here, for example. When time is 9, 9 minus 1 is 8, 80. For example, 8 minus 1, 7, 70. This way, we can calculate the velocity of the car. So here it was a constant relationship, so we can see that the velocity is constant with respect to time. So you see that we are talking about the time. And then here the relationship is not very simple. So first it is linear, then it changes, that is with slope 1, slope 1, then again linear but in a different slope, and then different, and then different. You can see that it follows different curves, different functions at each time. Here again it is linear. So if we follow the overall cases, we can say that the s, the distance, it can be, for example, then at, linear relationship, or it can be parabolic one, or velocity can be a linear relationship, velocity can be constant, velocity can be a cubic one, etc. So these are the variables. But for any of these variables, we use that del s by delta t as our velocity, and then we use acceleration as the velocity change by the time. But as you will see in our next cases, we will look for a general case. General case means that instead of delta t, we need to look for the dt. Okay, and then if you look for dt, this one is a finite. But this one is infinitely small. Okay. Therefore, we will look for the general case, and general case says that v is ds by dt, and then a is dv by dt. This is the general case that we have to use. With that in mind, we will look for a parade of terminology. So we have a distance and we have the displacement. We have instantaneous velocity, we have average velocity, we have average speed, and then we have instantaneous acceleration and then average acceleration. And let's talk about these terms. The distance is, let me give you a one simple example. Say that the particle was here, point A, so initial, and then this is a point B, and then the particle moves this way, so it goes to point B, and then it goes back to here, and then let's call it this point as well, like a point C. It is like you can think of this one as like a Nashville, Huntsville, and then Cookville. And then if you look for the distances, let's say that this part is 70 miles, and then this part is the 80 miles. Okay, so then distance is, if you look for the distance, is 70 plus and one more 70 because it traveled here, and plus 80. So it traveled 70 miles, and then 70 miles, and then 80 miles. I ignore this curvature, ignore it, because then the calculation will be complex. So it will be that 220 miles. This is the distance, and then displacement is, this one is total. Displacement is that the final position minus the initial position. What is our final position? The point C. And the initial position is the point A. So, however, our object traveled in a path like this, from C to A is 80 miles. Okay, this is what we call as a displacement. And then with these cases in mind, because it will affect that how we define velocity, these are just definitions, yes, that is defined by someone as a definition. So these will affect how we define the velocity and then speed. Okay, distance and displacement, and the instantaneous velocity is, the velocity will be change of, so let's call displacement as the delta s and distance as st. Okay, so let's first tell average velocity, that will be easier. The average velocity is that the delta s, as you can see, the displacement divided by the time difference. Okay, but the instantaneous one will be ds by dt. Okay, this will be instantaneous velocity is ds by dt, and then average velocity is delta s by delta t. But the average speed is v speed average will be the total distance st. You can see that the total distance from A to B, from B to C, and divided by the delta t. Okay, so the time delta t is this delta t time used to travel the distance of st. And then instantaneous acceleration, it will be that change of velocity with respect to time, and then average velocity acceleration will be that change of velocity with respect to delta time. So we used these ones and then we did these ones in the graphs. So we did examples on this one, but the rest is just the terminology that we use to define the speed and the velocity and the acceleration. So next recording I will solve this simple example.